Hello grade 7, how are you today? Let's continue the third lesson of unit 1 as we explained the first part of it, which is talking about the chemical equation and the chemical reaction and what do we mean by the chemical reaction and the difference between the word equation and the symbolic equation and which one is better and why. Then we have to know that the equation should be balanced, and we said why before, to achieve the law of conservation of mass. So for example, this equation in front of you, the common one, when you burn the magnesium in the presence of oxygen, so we have Mg plus O2 to give us MgO. Is it a balanced equation? Of course no. Why? Because the Mg and the oxygen, and this represent the reactants, and the MgO, which represents the products, they are not equal in the atoms, they are not equal in the masses. So to balance the chemical equation, you should have the Mg and the O2 in this example equals in the reactants, equal in the product. How? Here we have one atom of Mg and O2, it's a diatomic, so the oxygen molecule consists of two atoms of oxygen. They yield MgO. How many magnesium in the reactants? 1. How many magnesium in the product? 1 also. Here, how many oxygen in the reactants? Yes, we have 2. And here we have only 1 oxygen. So you must balance the number of atoms of oxygen. How? We are going to put 2 here. That's why we have 2 MgO. But we have another problem, that here we have 2 magnesium and here we have only 1 magnesium. So that's why we should put here 2 also. Is it balanced right now? Of course it's balanced. We have 2 Mg in the R, 2 Mg in the P, or the product. In oxygen we have O2 in the R, reactants, and here we have 2 oxygen. But be careful about this part, because this is a common mistake and you said that we have 1 oxygen here. No, because the 2 is for Mg and O also. So we have 2 oxygen and 2 magnesium. The chemical equation should be balanced. This means that the number of reactant atoms equals the number of products atoms. Why? To achieve the law of conservation of mass. What is the law of conservation of mass? The total masses of reactants equals the total masses of products. Let's apply this law in some examples that we have. If you know that the atomic masses of magnesium 24 and oxygen 16, prove that the following equation achieves the law of conservation of mass. 2 Mg plus O2 yields 2 MgO. Okay, to answer this question, you should calculate the reactant mass individually, then the product mass as well. If they are equal, so this achieves the law of conservation of mass. If they aren't, so this is unbalanced equation, or there is something wrong in this equation. How to solve it? First of all, you are going to write that the sum of reactants masses equals the magnesium here equals 24. And how many magnesium that we have? 2. That's why I have 2 times 24. And instead of magnesium, you are going to write its number, the atomic mass of it. Okay? Plus O2 means O equals 16, and we have 2 atoms of oxygen. That's why we have 16 times 2. The sum of reactant masses here is 80. 2 times 24 plus 16 times 2 equals 80 gram. This is the first part. On the other hand, the sum of product mass, where is the product? Here, 2MgO. This means that we have 24 plus 16. Okay? So we are going to solve it as the following: 2 open bracket 24 plus 16, and it equals 80 grams. Okay, are they equal, the sum of reactant masses and the product masses? Yes, they are equal. And if they are equal, so this equation achieves the law of conservation of mass because it's a balanced equation. Okay, let's move to the second part of this lesson, which is talking about direct combination reactions. You have 3 types of it. Number 1, element plus element, element plus compound, and the last one is compound plus compound. You should know some example for each type of these. First, we have an element with another element. The first example, this is called, yes, carbon plus oxygen yields carbon dioxide. So when I burn a carbon in the presence of oxygen, it produces carbon dioxide. Which type of reaction this represent? Element plus element. Why? Because carbon is an element and oxygen also is an element, similar atoms. So element plus element producing a compound. So this is the first type. Another example, if I have 2Mg element plus O2 also element, they producing 2MgO. Okay, so this is the first type of direct combination reactions. Element plus element, carbon plus oxygen, carbon dioxide, magnesium plus oxygen yields magnesium oxide. Okay, the second type, element plus compound. For example, this is called carbon monoxide. Carbon monoxide. Is it an element or a compound? Yes, it's compound. Why? Because it consists of 2 different elements, carbon and oxygen, plus O2. Element or compound? That's right, element. So we have a compound plus element, and this gives us 2 carbon dioxide molecules. In the same way, if I have nitrogen monoxide plus oxygen, it yields 2 nitrogen dioxides. Compound plus element and compound plus element. This is the second type. Okay, the last type of these reactions, ammonia plus hydrochloric acid. Ammonia, we talked it before, as a gas is NH3 plus hydrochloric acid HCl, and the condition for the acid is concentrated, okay, not diluted. So we have here concentrated hydrochloric acid. They producing NH4Cl, which is called NH4. We took it in the atomic group that represent ammonium chloride. Ammonium chloride. And by the way, when it produces the ammonium chloride, it produces a white fumes or white clouds. And here is a question, give reason, very important one. When adding ammonia to hydrochloric acid, white fumes are formed due to the formation of ammonium chloride, and you should write the chemical equation. So here we have NH3 plus HCl give us NH4Cl. Okay, this is the last type of reaction. The last part of this lesson, which is talking about the positive effects of the chemical reaction. Of course, we use a chemical reaction in our daily life a lot in different fields like medicine, fertilizers, plastic, and fuel and other compounds. So this is the positive effect of the chemical reaction. But do we have a negative effect for it? Of course we have. And you should know the compounds and their negative effects for each one of them. For example, I have carbon monoxide. Would you tell me the symbol of it? We said it before. Yes, CO. CO is carbon monoxide. Carbon monoxide causes a lot of harmful effects like headache, fainting, and stomach aches, and may lead to death. Okay. Carbon dioxide, we took it in grade 6, that increasing the temperature of the earth and causing the global warming. So it's called greenhouse effect, and it causes global warming. Here we have sulfur oxides, and the sulfur oxides, by the way, they are acidic gases, and these gases causes respiratory system malfunction, which means breathing problems and building corrosion. The last type of gas that we have, nitrogen oxides. It's a poisonous and acidic gas, by the way, and it affects the nervous system and the eye. Okay, and the last negative effect that we have, burning of coal and cellulose fibers such as paper and cigarettes, cause two things, which are air pollution and lung cancer. Here's we finished the first unit. Hope that you are doing great in your study in this lesson. If you please, it's supposed to answer the worksheet and the science book, and maybe we have inshallah online meeting to discuss this with you. Thank you.